Okay, gang, this is the last section of chapter 1. What do you think? We'll be on to chapter 2 next week. This is 1-4, and we're going to use the trig functions that we learned last chapter. What if I wanted to find the cosine of negative 900 degrees? We're going to have to use what we learned about coterminal angles, right? Negative 900 degrees is coterminal with what? Let's take negative 900 and add 360 a few times and see what you get. I think if you add 360 a few times, you'll see that you get negative 180, right? So let's add 360 again. Might as well get up to 180, right? Does that make sense? Okay, so 180 degrees, I know the cosine of 180 degrees, and if I know the cosine of 180 degrees, I know the cosine of negative 900 degrees, right? The cosine of negative, or the cosine of 180, sometimes I just look at it and I think, what's that point? That point is negative 1, 0, so the cosine is negative 1. In case I forgot. Sine of negative 900 would be the same as the sine of 180 degrees. Okay, so that's the y-coordinate over r. Remember, r is just 1. So the sine of 900 degrees is 0. Tangent of negative 900 is the same as tangent of 180. We're going to take the y-coordinate divided by the x-coordinate. 0 divided by anything is 0. Okay, so you use your coterminal angles and what you know about the sine, cosine, and tangent of our quadrantal angles. Okay, I want to show you some how we kind of do arithmetic with our order of operations with our trig functions. When you see this notation where the square is it's like sine squared of 90, okay, that's the same. We don't write this. I mean, you can. Okay, that means you take the sine of 90 and then you square it. They just kind of put the square there. You know why, guys? Because sometimes people write this and they square 90 and then take the sine. Okay, so this is what we mean when we say sine squared 90 degrees. We mean take the sine of 90 and then square it. It's a notation thing that you'll just have to kind of get used to. Okay. So I know that the sine of 90, gee, sometimes I just, okay, 90, I draw the, axis here. Draw the coordinate system. This is the point 0, 1. Okay, I'm going to need 270, so I'm going to need the point 0, negative 1. Looks like I'm using 360. So to go 360 degrees, I would be at the point, 1, 0. Okay, or maybe you have some of these memorized already. But I have 5 times. Let's see, the sine of 90 would be the y-coordinate. Sine is y over r. 1 over 1 is 1. The cosine of 270. So that would be the x-coordinate over r. So that would be 0. And the tangent of 360 is, let's see, y over x, so 0 over 1. So I'm going to have 5 times 1. Ugh, that's just going to be 0. It's just going to be 5 because the other thing's 0 out. Okay, so the answer is 5. All right, so just you'll be doing a little bit with that arithmetic, and you can do that on your calculator. I'm aware. We'll look at that in class. Reciprocal identities, we already talked about. Sine is 1 over cosecant. Cosecant is 1 over sine. They're reciprocals of each other. Cosine and secant are reciprocals of each other. Tangent and cotangent are reciprocals. This is how, a formal definition of the reciprocal identities. Okay, I always remember if one of them has a co, then its reciprocal doesn't have a co. Because some people used to get mixed up. They thought sine and secant were reciprocals. Well, neither one of them have a co. All right, so the reciprocal of sine is cosecant. The reciprocal of cosine, already has a co in it, is secant. And then tangent and cotangent we usually don't mix up. Okay, so what if I was given this? I was asked to find the cosine of theta. I don't know what theta is, 10 degrees, 20 degrees, I don't know. But I do know that the secant of theta is 5/3. Well, cosine and secant are reciprocals of each other. So if you tell me the secant of theta is 5/3, I know that the cosine of theta is 3/5. Okay? Tell me the sine of theta, given that the cosecant of theta is negative square root of 12/2. Okay, well, I'm going to tell you that the sine of theta is also negative, but it's 2 over the square root of 12. Okay, now in the future, I know I said you don't have to rationalize the denominator, and I'm still saying that, but you will be asked, I don't want radicals that are not simplified. Okay, 12 is 4 times 3. Okay, square root of 4 times 3 is square root of 4 times square root of 3, and I can take the square root of 4. It's 2. Okay, so I would expect that you would have changed this to negative 2 root 3 over 3. I'm sorry, over 2. So that we can see that really this is just the negative square root of 3 is what cosecant is. All right, they didn't give me it in simplified form. And so that my sine of theta would be negative 1 over the square root of 3 is what I would want to see. If you want to rationalize it and write negative square root of 3 over 3, you'll get a little extra credit. But you don't have to rationalize it. You don't have to have the square root not in the denominator, okay? But you do have to simplify radicals. You see the difference? Okay, I don't want to see the square root of 12. That's 2 root 3. And we could have simplified that much easier to negative 1 over the square root of 3. Okay? Now, we want to think about where the trig functions are positive. Okay? So I'm just going to look at how I get in the first quadrant. I have to have a positive x and a positive y. To get in the second quadrant, I'm going to have a negative x, but still a positive y. To get in the third quadrant, both my coordinates are negative. To get in the fourth quadrant, I do have a positive x, but I have a negative y. Okay, so then we think about it. Heck, if both of our numbers are positive, all the trig functions will be positive in the first quadrant. Okay, all trig functions are positive here in the first quadrant. However, over here, the x coordinate is negative. So think about which trig functions use x. Cosine, tangent, right? And of course, they're reciprocals, secant and cotangent. All right, so the only ones that are positive here, sine is positive because it's the y coordinate over r. Sine will be positive, and of course, its reciprocal is kind of, we know that's positive if sine's positive. I guess that's it, huh? Because x, we use x in everything else. Here, both are negative. So the only time we get positive is when we take a negative divided by a negative, which would be y over x or x over y. Right? Those are the only things that are positive in the third quadrant. In the fourth quadrant, x is positive. So the things that use x will stay positive. Let's see, that would be cosine. Right? Cosine uses x. So does secant then. Tangent uses x and y. And so cotangent, right? And sine, of course, uses y. So there you go. All the trig functions are positive in the first quadrant. The only two that are positive in the second quadrant are sine and cosecant. The ones that are positive in the third quadrant are tangent and cotangent. And the ones that are positive in the fourth quadrant are cosine and secant. It helps a little bit to be aware of that. Okay, but you can always draw the angle out and remember it. Okay, so like we said, in the first quadrant, they're all positive, right? In the second quadrant, the only things that were positive were sine and cosecant. Everything else was negative. In the third quadrant, we just had tangent and cotangent being positive, and the rest were negative. And of course, in the fourth quadrant, we just had cosine and secant, and the rest were negative, okay? It's not necessary to memorize this chart. Understand why, because of the, coordinates, the X, Y, and the R. Understand why they're positive or negative in the certain quadrants, and you can reason each problem out, okay? So 87 degrees, determine the signs of the trig functions, okay? Signs. Notice the spelling. Okay, so I just want to know if they're positive or negative. So I know that the sine of 87 degrees is going to be positive. The cosine, this is in the first quadrant. You know what I'm going to write? They're all positive. It's in the first quadrant. 300 degrees, I have to think about that. That's more than 270. So I end up in quadrant 4, where my x is positive, but my y is negative. So this is one of those where I have the cosine is going to be positive, and of course the secant, because I'm in the fourth quadrant and my x coordinate is positive. Negative 200. That's more than going negative 180 by a little bit. So I'm going to end up in the second quadrant where x is negative, but y is positive. So my sine is going to be positive. And of course, my cosecant will be positive, okay? Depending on where I end up on the coordinate system, will tell me if I'm positive or negative. Okay? That makes sense? Okay. Identify the quadrant or possible quadrants of the angle that satisfies the given condition. Sine is positive. That's what that means, greater than 0. And tangent's negative. Sine's positive, but tangent's negative. Well, sine, which uses the y coordinate, is positive in 1 and 2. Which one of those is tangent going to be negative in? Right? Because it's a negative x, positive y. So when I take a positive over a negative, I get a negative tangent. So that's quadrant 2. Where is cosine positive? Cosine's positive where x is positive, so that's 1 and 4. And secant negative? Where is cosine? Oh, that's not saying positive. Oh my goodness, I was like, that can't be. Where is cosine negative? I read that wrong. That's over here in 2 and 3, right? Where x is negative. That's where cosine's negative. And secant negative. Well, they're the same always. Cosine and secant are always the same. So 2 and 3. Okay? Anyway. Suppose the angle theta is in quadrant 2. Okay, I always like to draw it. Let's go to quadrant 2. There we go. There's my theta. Sine is 2/3. Find the other 5 trig functions. Well, if sine is 2/3, that means y is 2 and r is 3, right? I need to find x. I know that r squared equals x squared plus y squared. So x squared equals 5. So it looks like x is going to be the square root of 5. Or is it? I'm in quadrant 2, guys. What kind of x gets me in quadrant 2? Okay, be very careful. X is negative the square root of 5. Okay, to be careful here. I should have put plus or negative there. So once I have x, of course, I can find the rest. Cosine of theta is negative square root of 5 over 3. Tangent of theta is what? Y was 2. Oh, or almost out. Sorry, I'll continue this next one.